Welcome all, and I especially mention every scientist and researcher in this conference, Second International Conference on Big Data Modeling and Machine Learning, BML21, and thank you for accepting my research for presentation in this great event entitled Optimization the Storage Sites for Export Inbound and Reorganized Containers by Timing Location. This work is presented from Mohammed Saleh and in partnership with Attariuas Hicham, Mohammed Maâti, and Hatem Taha, Computer Science and System Engineering, Faculty Science, Abdul Malik Al-Saudi University, Tétouan, Morocco. Today, in light of the continuous movement of the ports and their large congestion, the seaports are facing an increasing growth in the accumulation of containers. Countries are striving to make the most of these ports and increase their share of the resources of this sector, as well as improve their competitiveness. Despite this increase, the ports suffer from many problems, including how to take the appropriate decision to store and unload containers of all kinds, and the idea of sustainable and clean ports as a major economic alternative has become close to our thinking, especially with the epidemic sweeping the world today. The problem? There is a problem when staking and storing incoming, outgoing, and reorganized containers, and the inability to take the appropriate decision to choose the optimal place for new containers, whether arriving or outgoing in the yard. The problem can be summarized in the following points. 1. Random staking and increased operational cost. 2. The difficulty of investing in the infrastructure. 3. Absence of informed decision-making in real-time staking, discharging, and reorganizing containers. 4. Absence of an effective methodology for applying artificial intelligence. Problem handling. The problem has been studied in all respects and found that the best solution to such problem is to use time timing for the container slots in the yard. So, we see that the problem can be solved by proposing the hypothesis of bay double chronic. This hypothesis provides optimal storage location for containers arranged by appropriate departure time to avoid the random accumulation of containers and reduce force movement of previously stored containers, as well as facilitating the decision to move the containers stored in the terminal to allow the provision of new storage places and reduce the time and cost of operation. For example, if we take the weight factor will be recurring and affect the stacking of outgoing containers more than incoming, and we can take the time factor as well, but the time factor is present with all cases of the containers and change continuously. In this part, I want to explain the paired way method in the block. In this approach, we first present two-part methodology of by timing. The first is the allocation of double bays in the block, and the second part addresses the problem of allocating ideal sites for storing containers. In general, the method divides the block into paired bay, in which the incoming, outgoing, and refrigerated containers are stored with taking into account the characteristics of each type. The methodology is mainly based on the exact time for each container location, which gives the paired bay the time mechanism. Then we determine the ideal location for the container by the previous content of the bay with the inclusion of the variable related to the bay and the containers. The containers are stored in chronological order according to the time diminution rule. Farthest date is first in, and in the export according to the rule, earliest date first out. The numbers represents their distinct chronological order in the squares. The method consists of flexible construction of for dynamic storage and container retrieval. The presence of Fourier storage means that there is a given configuration of the block, even if partially. So, storing containers based on time implies that the retrieval sequence process will be well defined, and this in turn affects many aspects. The ways we tackle the problem. First way is mathematical method. Second way, the scenarios. The third way, attempting to apply the methodology to the practical reality in the port of Al-Qasr al-Saghir, Morocco. Science, we need to collect data through which we can apply artificial intelligence. As we see that neural networks will serve us greatly as we try to reach models that predict containers storage locations through stowage errors or through studying the historical models of data. Conclusion. Ports are facing increasing pressure in container storage. There are mathematical methodologies and there are personal decisions. We are trying to go to introduce artificial intelligence through this method to solve the problem. Thank you.